introduction. I was actually planning on focusing on the Barents Sea Cod, and I work on the effect of climate change on cod, on Atlantic cod. However, we do the same work parallel also on the Western Baltic stock, and since some of the results are not in for the Arctic Norwegian cod, I will also show you the results for the Western Baltic. So, yes, and since the early life stages tend to be the most vulnerable to changes in pH and all of this, I'm actually focusing on the recruitment, so on the cod larvae. These are actually our survivors from one of the experiments, so they're really beautiful creatures. And we are looking into how the recruitment might change in the future when we take climate change into consideration. And I don't know how many of you are also staying at the Albert Hotel. It's really nice. It's named after Albert Einstein, actually. And they have all these quotes on the wall. And this morning when I woke up, I realized that the quote about my dad says, I never think about the future because it comes soon enough. So I don't want to disagree with Albert Einstein at a scientific conference. That seems like a sure way to enter a career, not start it. But I hope that in about 9 minutes from now, we're going to agree that if he had known a bit about climate change in fisheries, he might have changed the statement at least a little bit, or I hope so. So to look into the effect of ocean acidification, we've been running experiments for a few years now. And I've actually been showing the experiments last year in the ocean acidification session, so I don't want to go into much detail about this. So I'm just going to refer you to the paper if you want more details on this. It just came out, so feel free to look into it and cite it and comment. And so I'm just going to give you a summary on the experiments. The first one we did on the Baltic cod, and that was run in Kristineberg in Sweden. And we always compare what we have now, so ambient seawater, to about 1,000 microatmospheres of CO2, which is under the IPCC pathway 8.5, so business as usual. It's what's predicted for about the year 2100, around there. So it's quite a realistic scenario that, especially in the more coastal regions, could totally be reached. Here they were fed with natural plankton, and we had 3 replicates. And we were actually able to count all the dead larvae every day in the tanks, so we actually have a proper daily mortality for this. Then for the Arctic Norwegian cod, we were lucky to run this in an aquaculture station in Tromsø. So it's a more, it's an aquaculture setup, so more professional in that way. And we were also able to have more replicates, so we have 6 replicates. And because we had way more larvae in the tanks, we started with about 12,000. We couldn't actually count the dead ones every day, so it's just a larval density measurement in the tanks, but that worked pretty well as well. So what I'm looking at is the actual survival of the larvae throughout the experiment. These are the dead larvae. And this is the result for the Western Baltic cod. So the blue dots and the blue line is the control, so with ambient seawater, as we have it now, and the orange is what we saw for the high CO2 treatment. So as you can see, the survival under high CO2 is much lower than it is under seawater concentrations as we have them now. And it's actually, when you look at the curves, it's actually a doubling in mortality rate from ambient to high CO2. And we were quite surprised that the result for the Arctic Norwegian cod, so when you compare, is pretty much exactly the same. We also had a doubling in mortality rates. I mean, the survival is slightly higher in general, just because it's an aquaculture setup and it's slightly more professional. We also looked at an effect of food concentration, so whether they could maybe cope better if they had more food, but that had no effect on the survival, so I'm just combining it here together. Then the next step was to see what does that actually mean for the population, for the recruitment. So we included the survival data into standard stock recruitment models. And this is the result. So just to explain, we had the extra mortality was still going on when we ended the experiments for logistic reasons. So we had to decide what we think until which point does this extra mortality actually happen. And we chose 2 developmental stages where we think maybe afterwards they would be able to cope better, and maybe that's where it would end. So one of them is the point where the gut spirals, here. And the other one, which makes a lot of sense, is when the gills are developing, because the gills are the site where the actual osmoregulation is happening. So once they've actually formed the gills, maybe they would be able to cope better with the pH changes. And then, so that's these 2 points on the graph. One is at 23 days, and the other is at 30 days. And then we used the recruitment as we have it from the IC's data from the past few decades as kind of the baseline. And then, so it's just comparing it to the baseline here. And as you can see, the top one is the Barents Sea Cod, the bottom one is the Western Baltic Cod. You can see that the recruitment goes way down. Even if we just go to 23 days with the added mortality, we end up with values, well, around 25 and below 10% of the recruitment as we have it so far. So this is just a different way of showing it, just a standard stock recruitment function as you see them quite often probably, with the spawning stock biomass at the bottom and then the recruitment. And again, we have the 2 different developmental points that we chose. And it actually looks quite dramatic when you look at it just like that. But please also notice that actually the ocean acidification recruitment is even on a different axis. So it's quite a dramatic change between these 2. And this is the same graph for the Barents Sea stock with pretty much the same picture. Again, it has also a different axis, so the effect is quite dramatic. And if that wasn't bad news enough, we thought, you also have to look at temperature effects. And this is the part that we don't have for the Arctic-Norwegian cod yet, but it's a work in progress and it's going to be available soon, hopefully. So we looked at the temperature data in the Western Baltic from 1978 to 2015 and tried to see which data actually explains the recruitment in those years best. And it was spatially resolved, not just geographically, but also in different depth layers. And then we chose the month and the depth that kind of explained most, which happened to be November and March, which makes sense because November is kind of the part where the gonadal development in the adults is happening, and then March is where the actual recruitment is happening. And then, so these temperature-dependent stock recruitment models that resulted from this also show that with increasing temperature, the recruitment also goes down. And that's what we can see here. So this is all assuming MUI, so under optimal management in that sense. And here we have the spawning stock biomass and the catch. And the x-axis is always the temperature increase. So here it goes from 0 to 2.5. And you can see with increasing temperature, the stock goes down, the catch goes down, and then here we also have the fishing mortality and the profit. It goes down quite dramatically, but even at 2.5 degrees Celsius increase, you still have the fisheries. It's still under optimal management, it's still running. So we thought we'd add the temperature and the ocean acidification together, see what happens then, and this is what happens. So the x-axis doesn't even actually go to 2 degrees increase anymore because it's already collapsed at 1.8. And yeah, so at this point there's not going to be anything left. And so basically to conclude, even if we stick to the 2 degrees increase goal with the added acidification as well, it's already pretty bad news. And even the more optimistic goal of 1.5 degrees increase, which I'm not even sure anyone believes we can manage to reach, but even that would have quite a dramatic effect on the cod population. So that was my talk. Thank you very much for listening, and thanks to everyone who's involved.